In our last lesson, we learned about the law of sines, and that the law of sines can be used to solve for missing pieces in a triangle when it is not a right triangle. So the first type of trig that we did, we learned about SOHCAHTOA. And SOHCAHTOA can only be done in a right triangle because it is based on a hypotenuse, and a hypotenuse only exists in a right triangle. So then, in our last lesson, we talked about what do we do when we don't have a right triangle, and we learned our law of sines. Law of sines can only be used when we know both parts of one letter, so we need to know a matching angle and side. And we talked about how in our triangles we name those across from each other, that a side is named across from an angle. So the law of cosines is what we do when we don't know both parts of one letter, and it's not a right triangle. The law of cosines formula is a lot messier than the law of sines formula. So I told you that you didn't need to memorize the law of sines formula, but by the end of the homework, you probably would have it memorized because there just isn't a lot to it. You still don't need to have it memorized. It'll be on the quiz. This one you also do not need to memorize. It will be printed for you on the quiz, and you probably won't have it memorized because there's a lot more going on in this one. There are 3 of them here. They are all actually the same formula, and I'm only going to print one of them on the quiz. So it is important that you understand how the formula works and how we can kind of shuffle stuff around as needed. These they look like negatives in the front. It's bad. PowerPoint did that for the bullets. So these are actually bullets. They're not negatives in the front of those equations. So that looks bad. On your sheet, it actually uses an open bullet, so that works better. But what is important to note about these equations is that whatever little letter is on the left-hand side all by itself, that is the same big letter that's inside of the cosine for the angle. So the little one that's all by itself matches the big one that's for the angle, and all of the other ones are the other 2 letters. Okay? So if little a is alone, we have little big A over inside of the cosine, and we use little b and little c throughout the formula. Okay? If little c is all by itself, then big C is our angle, and we use the other 2, little a and little b, throughout the formula. Okay? So we can kind of move around letters that way. I'm going to give you the formula on the quiz, but I'm only going to give you one copy of it, so you have to know that you can rearrange the letters as you need to. Okay? If we ignore the end of this and just kind of look at the front part, if we just ignore all that messy trig part, what does this equation kind of remind you of? A squared plus b squared equals c squared. It's the Pythagorean theorem up there. Really. So the Pythagorean theorem is only true in a right triangle. So the Pythagorean theorem is really kind of a special case of the law of cosines. That in a right triangle, we get to ignore all the messy trig stuff and just do a squared plus b squared is c squared. But if it's not a right triangle, then we have to bring in that trig stuff at the end, and it becomes the law of cosines. We're going to set up our problems the same way we did yesterday, or in the last lesson, by listing out what we know and need to know. In the previous lesson, we either knew 2 angles, so we could start by subtracting from 180 to find the third angle, or we knew a matching angle and side. In this lesson, we won't, most of the time. Now, the homework is cumulative, so that's still always the question I start by asking myself. And when it comes to the quiz, I'm not going to say use law of sines or use law of cosines. I'm just going to give you the information, and you have to know which one to use. So I always start by checking, do I know 2 angles and I can just subtract from 180, because that's easier than trig? Or do I already have a matching set? And if so, I use the law of sines, because the law of sines is a lot neater and cleaner than that big law of cosines formula. But on this one, I don't have any other option. I have to do the law of cosines. So I'm going to use the form of the law of cosines that has the little b alone, since that's the thing that I want to solve for. So that uses little a, little c, and the big angle b. So again, you don't have to memorize that. Probably won't by the end of the assignment unless you have one of those memories that just things click quickly. That's not me. Sadly, I do still have this memorized, so I feel like I'm wasting brain space, but it is what it is. Then we're going to plug in what we know. So I know side A, I know side C, and I know angle B. So on that right-hand side of the equation then, everything is a button I can press on the calculator. Okay, they're all numbers, pluses or minuses, squares, and cosines. Those are all buttons on the calculator. So I can type all of that into the calculator in one piece. Now if you're using like a regular graphing calculator or something, you just type it all in one piece exactly like it's written. And I get about 97.4. Now, if you're using an iPod or an iPhone, you can still do this, but it's a little bit more annoying because we have to type everything in backwards. You'd have to start at the end and do 38 cosine times 16 times 12 times 2, and then you actually need to just write down that answer now. And then you have to start back at the beginning and do 12 squared plus 16 squared minus the answer that you had gotten for that end part. So it works, it's just a messier process.
You can copy it here.
Not on the iPhone.
You can hold it and then hit copy.
Oh, you can? You can copy the answer? Oh, that's nice. I didn't know that. This is not our final answer yet. If it were, it'd be a little strange because the other two sides of the triangle are 12 and 16. So then for the third side to be 97, that seems a little bit out of whack. Okay? But this is a super common student mistake. So there's kind of 3 red flags that I'm going to warn you about that are the big mistakes that students usually make on these problems. And this is the first one of doing this and then writing that down as your answer. This is not our answer yet because that's not what b equals. That's what b squared equals. So if I want to know what b equals, what do I need to do? Take a square root of it. So now on the calculator, I need to take the square root of that 97.4 and more decimals. And I get about 9.9, or we could just round that up to 10. Okay, so that's the first common mistake that students will make is forgetting to take the square root there. So be careful of that. Your answer seems a little bit absurd usually if you don't. Sometimes it's not quite as obvious that it's out of whack, but usually it seems a little strange if you don't.
From here, could we use the law of sines to find the other two?
Yep, so now at this point we're going to go back to our law of sines because now we know both parts of one letter, and the law of sines is easier than the law of cosines. So as soon as I'm able to use the law of sines, I want to revert back to that one. So now we're going to set this one up like the previous lesson. Sine of 38 over 10. Now, it can matter which angle you solve for first. It does not every single time, but to figure out whether or not it's going to matter requires a couple of steps of a thought process. So instead of going through that, I'm just going to say let's always be safe instead of sorry. Always go for the smallest remaining angle first. It does not matter in every single problem, so sometimes if you do it wrong, you'll luck out and you'll be fine. But sometimes it does matter. So in every problem where you're solving for more than one angle, always go for your smallest remaining angle first. So how can I tell whether I want to go for A or C? The smaller side. The smaller side will make a smaller angle. So I want to go for angle A here, which means I need to use side A as my denominator. So then this is like our previous lesson, and to solve this, we're going to multiply both sides by 12. And type that in the calculator. And I get 0.73879, blah, blah, some more decimals. That's not our answer yet because that's the sine of A, so what do I have to do to find out what A is?
Inverse sine.
The inverse sine on the calculator, the second sine of that decimal. And that gives me about 47.6, or I'll just round that up to 48. To find your third angle, always just subtract from 180. It is easier than doing trig, and it is actually more accurate, because if you would try to go through and do another law of sines with this, you might end up getting a wrong answer. The correct answer is 94. Now the reason why we always need to go for the smallest angle first is that when we're solving for an angle on the calculator, we have to do that inverse sign or second sign. And the calculator is programmed in such a way that it will only give you an acute answer when you do that. So if the true answer is supposed to be obtuse, it will actually give you a wrong answer, not an error message. So if we had tried to go for angle C first here, it would have given us a wrong answer. The answer it gives us has meaning. It's actually the same distance away from 90 on the other side. So this one was 94, it's 4 degrees off of 90. The calculator would have told us the answer was 86, 4 degrees off the other way. It has some meaning to it, and we'll, as we progress into some later trig, we'll talk about where that is coming from. But it's wrong, and it doesn't give you an error message, and so it really is risky in doing that. So always go for your smallest remaining angle first, and that will leave the biggest one left over to just find by subtraction. So if it ends up being obtuse, you'll be fine. Okay? So always go for your smallest angle first.
If you mess up the law of cosines in the beginning, then you're going to get all three wrong.
Yes, this is a problem where answers build from one part to the next, which is a little bit of a bummer that once you get one part wrong, everything's wrong after that. On the homework, I don't take the time to say, oh, okay, you got this one wrong, so let's work through with your wrong answers, because, you know, I have like 70 geometry students. I'm not going to do that for 70 students on homework. When it comes to the quiz, I will follow through with you, though. So another reason why it's going to be really important to show your work on the quiz is if you get the first answer wrong, everything else will be wrong. But if I can see that you were doing the right thing, but building off of a wrong answer, you'll still get all of your points after that first one. Okay? So showing work is going to be really important on this when it comes to the quiz. All right, let's do another one. So I do not know two angles, so I can't subtract from 180. And I don't know both parts of one letter, so I can't use my law of sines. So this is where law of cosines becomes necessary. I want to use the law of cosines that has the little a alone, since that's the one that I'm trying to solve for. And so then we'll plug in what we know. And everything over on that right-hand side is a button I can press on the calculator. So I'm going to go ahead and type it all in. And I got 714 and some more decimals after that, which would be a really big side to go along with 19 and 22. This is not our final answer yet. That's a squared. We need to take a square root of that. So I get about 26.7, and I'm just going to round that to 27. Questions on that part, because that's the new part for today. From here on, this kind of turns into the same types of problems that we had in our last lesson.
Well, how do you know which formula to use?
I first decide between the law of sines and cosines based on whether I know both parts of one letter or not. So since I didn't know both parts of any of the letters, I know I have to do the law of cosines. Then between the three forms of the law of cosines, I want to choose the one where the thing that I want to solve for is all by itself. So since I wanted the little a, I wanted the one that has the little a alone. So then to complete the problem, yeah.
And How do you know which one to start solving for out of the three, A, B, or C?
Solve for the side first.
Side.
It's easier to solve for a side than an angle. So then, to complete the problem, we're going to go back to our law of sines, since we know both parts of one letter now. So sine of 81 over 27. And then do I want to solve for B or C first? C, because side C is smaller, angle C will be smaller. We're going to multiply both sides by 19. Type that in the calculator. We get a long decimal. And we'll take our second sine, our inverse sine of that, to get 44 as our answer for C. Once you know two angles, always subtract from 180 to find out what's left over for the last one. It is faster and easier than doing trig. And more accurate. The 0.695 came from typing the 19 sine 81 divided by 27. And then do the second sine of that. Yeah. We talked about in the last lesson how we don't have any way to quickly make sure that our answer is right, but we do have a way that could quickly let us know if our answer is definitely wrong. We want to make sure that our biggest angle matches our biggest side and our smallest angle matches our smallest side. If that lines up, it doesn't guarantee your answer is right. But if it doesn't line up, your answer is definitely wrong. Okay. In this one, it wouldn't have mattered which angle we solved for first because there weren't any obtuse angles. And we actually could have known that kind of right from the beginning because 27 is the biggest side. That means 81 would have to be the biggest angle. So there aren't going to be any obtuse angles. So we could have gone for angle B or angle C first, and it wouldn't have mattered in this case. But I just make a habit of always going for the smallest one first because then I don't have any risk. Okay? We have one more setup for this type of problem. So far we've had some combination of knowing sides and angles. Okay? And we've either known some sides and some angles, two or one of sides and angles. It will never work to know all three angles. That's not possible because I can have a little tiny triangle that has certain measurements and a big triangle with the same angles, but all the sides are bigger. Okay? So knowing all the angles will never work. But our last case is what we do when we know all the sides. As is often in a math class, as we progress through different types of problems, the last one is usually the most difficult, and that's the true story here as well. So just a heads up on this, that this is our worst case when we know all the signs. So, when we know all the sides, we still want to go for our smallest angle first. So what's our smallest angle here? A is going to be the smallest angle. We don't know two angles to subtract from 180. We don't know both parts of one letter, so our law of cosines is necessary here. I'm going to use the law of cosines that will give me the angle that I want. I want angle A. So I need the big A to be in my law of cosines, which means I need the little a to be alone. Okay, so of the three different forms of that law of cosines, I want to choose the one that's going to give me the angle I want. Since I want the angle A, I need the big A in it, which puts the little a alone. Then we plug in what we know. We cannot type this all in one piece because if we look at the right-hand side, it's got a variable over there and we can't hit a variable button on the calculator to have it give us the answer. So we don't know what A is and the calculator doesn't know what A is yet either. So we need to type this in three groups. The first group that we're going to type in is the left-hand side by itself. That kind of makes sense that that would need to be all by itself. Then our second group is going to be the other squared stuff. And that gives 493. And our last group is going to be the multiplied stuff.
What do you do with the minus symbol? You just bring it down.
Just bring it down. Yep. Now at this point, I want to take a little side note. You don't have to write this down if you don't want to, but there's a really common mistake that happens here in solving this equation that I want to show you you actually know better than, but once the equation gets messy, we forget that we know how to do this. So if I had 6 equals 4 minus 2x, what would I need to do first to solve that equation?
Minus 4.
I would subtract 4. And then what would I do? Divide by negative 2. Okay, so that equation, not too much of a problem for us. However, once our numbers get big and our x changes from being just a plain x to a cosine of something, students forget that they know how to do algebra. Okay? It is pretty rare that at this point in a student's math class that I would see them do that 4 minus 2x and make it into a 2x. Right? Early on in Algebra 1, a lot of times students will combine things we can't combine. But once we kind of get to this point, it's pretty rare that I see a student that would try to put the 4 and the minus 2x together. But once I come into this problem, it is extremely common for me to see students try to put that 493 and 468 together. Okay? This is the second big red flag. You cannot do the 493 minus the 468. Just like in that little side note, we can't do the 4 minus the 2x because this 468 has a variable attached to it. Okay? So, just like in that little side note, the first thing we needed to do was subtract. In this problem, the first thing to solve this is subtract. So we are going to subtract 493 on both sides. And then just like in that little side note, the next thing we did to solve was divide. The next thing we're going to do to solve is divide. Okay. So just like in that more basic algebra problem, we cannot combine the two terms that are not alike. We have to subtract off the front one and then divide by the coefficient. Same thing here, but that's not our final answer yet because that equals the cosine of our angle. So how do I find out what my angle is? Inverse cosine. So in the calculator, second cosine of that decimal. And I get about 23.55, or we'll call it 24.
And we're not even done.
We're done with the worst part.
That's only one part.
We're done with the worst part. That's the nice thing, like they get progressively shorter. The first one takes the longest, the second one's like medium, and then the last one's quick because you just subtract from 180. But the first one is definitely the worst one. Alright, so 2 big red flags. So my first warning of common student mistakes in these types of problems was forgetting to take the square root. Okay? So that last one, forgetting to take the square root, is a big thing that students will often do wrong. That sets everything kind of in a snowball of getting wrong answers. In this one, 2 big red flags. The first one is combining those two numbers, the 493 and the 468 here. Not allowed to do that. Thankfully, if you do that, later once you come and try to do your inverse cosine, your calculator is going to give you an error. So hopefully if you see that error, this little conversation will pop back into your head and you'll go, oh yes, I wasn't supposed to do that, and you'll go back and fix it. Okay? So thankfully that mistake will give you an error. Okay? Cannot combine the 493 and the 468. The second red flag is yesterday or in the last lesson we were only working with signs. So we just kept hitting that sign button over and over. Now sometimes we're doing sine and sometimes we're doing cosine. So hitting the wrong trig button is something you need to watch out for. Just make sure that you're doing cosine when you're supposed to do cosine And you're doing sine when you're supposed to do sine. Okay? So now to finish out this problem, we're going to go back to our law of sines. So I'm going to do sine of 24 over 8. And I want to go for my smallest remaining angle. Is that going to be B or C? C. Multiply both sides by 13. And do a second sine of that answer. So I'm saying be careful that you're hitting the correct buttons at the correct times. Yesterday it was all sines. Here sometimes it's sine, sometimes it's cosine.
Why don't we have a lesson like this for tangents?
There is no law of tangents,
Why is that?
as it's not necessary. The law of sines and law of cosines can do everything we need it to do. And then to find the last one, subtract our two answers from 180. And we get 115. So finding the first answer is definitely the worst process. Finding the second one isn't too bad with the law of sines. Finding the third one, easy, just subtract out from the 180. If you get the first one wrong, everything's going to be wrong after that, which is a little bit of a bummer in the homework, but on the quiz I will follow you through. Okay.
But that's a lot of fun to
Thankfully, this quiz usually goes well for the majority of people. So there aren't too many people that I have to follow through with them. So. All right, one more example of this.
Just go 10. 10. I'm just gonna set this one out.
Which angle do I want to go for first? A. So that means I'm going to use the law of cosines that has little a alone. And plug in what we know. When evaluating this, we cannot type it all into one piece. We need 3 pieces. The left alone, the squareds alone, and the multiplies alone. And the first thing to watch out for in this problem is you cannot subtract the 244 and the 240 and make it a 4. Thankfully, if you do, later on you're going to get an error. It doesn't tell you how to fix your error, though, so you need to remember we're not supposed to put those together. We subtract 244 from both sides. And divide by the negative 240.
That is the bet that Lippy doesn't want to all day.
Yeah, and that one actually divides out nicely. It's just 0.75. I didn't even round that. That's just what it is. But when we take the inverse cosine of it, it does get pretty messy. So you're going to take your second cosine of that 0.75, and it gives me about 41.4. I can just call that 41. Questions on that, because that is a new process to the problem. From here, we know both parts of one letter, so we can go back to our law of sines. So sine of 41 over 8, since those match. And do I want to do B or C first? C first. Multiply both sides by 10 to cancel out that denominator. And take an inverse sine of that, you get 55. So that was my second caution on this kind of problem, is making sure that you're doing the sine button when we need to do the sine button, and the cosine button when we need to do the cosine button. Once you have two angles, subtract from 180 to see what's left over for the last one. Questions? We have one more type of problem here to look at in the notes, which is to find area. No? You don't need to memorize the area formulas, as you haven't needed to memorize any of the other formulas. This formula works when you know all three sides of a triangle, and none of them is necessarily the height. So 1/2 base times height is kind of our plane area of a triangle formula, but this works even if none of those sides is actually a height. There are two parts of the formula. The first thing you need to find is S, which is called the semi or half perimeter. Perimeter means add up all the sides. So we're going to add up all the sides, find out what half of that is. Then that becomes S in that big square root formula. I have tried to prove this many times, and I can't prove it. So I can't tell you why it doesn't work. I always get stuck. But Heron apparently was smarter than me and came up with this formula that works, even though I can't prove it. It doesn't matter which one is A, B, and C. So our first step is to find out what is half of adding them all together. Okay, so we're going to add that all up and divide it by 2. And that gives me 56. Then the area part of it is the square root of S, which we just found is 56, and then S minus each of the answers individually. And it doesn't matter what order you take these in.
Just as long as you get each one.
Just as long as you use each one once.
Oh.
You can type that all into your calculator in one piece if you use parentheses the way that I have written the parentheses. So if you type that in exactly like it looks, square root 56 parentheses, 56 minus 22 close, open, and you do all those parentheses, it will work to type it all in one piece. Yes?
You're gonna have to
Question?
memorize it?
Do you need to
No.
Do you need to close?
You need to
the-
close the parentheses individually. The very last one doesn't matter.
Should we just always close the parentheses when we get sure?
That's the safest. I get 427.5.
Got it.
And that's it.
That's it. That's the answer. That's the area of that triangle.
It's so hard.
Okay? So the formula looks really messy. You don't need to memorize it. Add up all the sides, find out what half of that is. And then it's the square root of that half value times the half minus each individual side. So in this one, first step is find S, which is half of all the sides added together, and it doesn't matter which order you do them.
I think I'm gonna do the area problems first.
And I got 21.5. Don't round that. So we've been doing a lot of rounding. The worst it's going to be is a 0.5. Keep your 0.5. Don't round it. Okay, the decimal won't be gross on that S value. The worst it could be is a 0.5. So keep your 0.5
No, I won't take it anywhere.
because it's just one half of stuff added together. And I mean, it could be worse if your sides were gross, but I'm going to give you nice numbers for your sides. And I got 83. It's not nice. It's 83 point lots of stuff. I'm just going to call it 83.
Oh.
So, yeah. No, once we take a square root, it usually doesn't turn out nice.
But we can round the answer.
Yep, you can run your final answer, just don't run the S answer.
Done.
Your homework is a worksheet in the packet again. Now this is very important. On question number 4, there is a capital B that says that it is 4. That would mean an angle is 4. That would be a really small angle. It's possible, but not likely. That was actually supposed to be a little letter B. So make sure on question number 4 on your homework, you change that capital B to a little b. Otherwise, your answers are going to be very strange. Okay?
Gotta change the name.